Okay, we're in section 7 of the notes. It's integration by parts. This is the lecture portion of the notes. What we're going to do is have a short lecture. We'll explain what integration by parts is. The bottom line, though, for a lot of students, it's not telling them what integration by parts is. It's showing them through examples. So we'll go through a short lecture. It's not long. I do write the notes for you for a reason. We want to give you notes. So you have the access to the notes that certainly that I'm presenting as a teacher anyway. And then we'll get to the examples. But first up, short presentation of what integration by parts is. I want to emphasize, though, we're emphasizing a technique over here that works on the problems that we present to you. It doesn't work on every single problem. The problems need to be carefully written for this to work, but it is one of the techniques that you should know, right? So basically recognition you should know use substitution, and now you know another technique, or at least not yet, but you will today. You'll know another technique called integration by parts. So I'm going to switch over to the whiteboard. As I'm doing the whiteboard, I'm just going to talk about the 2 pages of lecture notes that we've given you. I'm certainly not going to read it to you verbatim, but we recommend you should read it verbatim. You should read the notes. All right. So let's go for this. I'm going to go to my whiteboard in a second. And again, the format of the course, generally speaking, we'll try not to talk too long. It's basically a show and tell. We'll get to the show and tell later. All right. The goal of this, though, is to get you to try. All right. So what does it say? Over here, it says, let's start with an example where you're asked to verify. Now, if I were asked to verify this integration over here, put it over here, the way I would verify it is I would just differentiate the right-hand side and make sure it gave me this back. So I'm going to verify or check this integration. So I write the check down. This is what I would do if I were asked to check this. And differentiation is so much easier than integration that I would definitely go for the differentiation. So I'm going to differentiate the antiderivative, which is x times e to the x minus e to the x plus c. Well, you know what? Differentiation to me is always easier than integration. So the first guy is going to be what? It's going to be, let's see, the derivative of x, which is 1 times e to the x, plus x times the derivative of e to the x, which is e to the x, minus, I just differentiate the first term. The derivative of the second term is just simply e to the x. And the derivative of c is just 0. So what do you get over here? Well, you get e to the x plus x, e to the x, minus e to the x. And what's nice about this, the e to the x's disappear. So left off with this. Now you should verify that this is in fact the integrand, and it is. So they're easy to check, all right? By the way, the work is over here as well. My chicken scratch typed up work. The main problem here, and I want to really emphasize this to you, the main problem here is not checking. It's how do they get that? So the main problem here is not the checking, but it's the actual process of finding the antiderivative. How did they do that? How did they find the antiderivative? Right? How did they find it? So what we're going to claim over here is that we're going to use a method that's nice, and we're going to write problems that reflect this nice method. All right. So one of the methods we've discussed before is use substitution. But I got to be honest with you, it's going to be aggravating to try to use substitution on that. It's just not going to go anywhere. All right. It's an important method. It's the first method I would try in any problem that I didn't recognize. But I'd be honest with you, it's going to fail miserably in this case over here. All right. So another technique that we're going to use is what's known as integration by parts. It basically is a product rule. So let me go through this with you. The derivative of this product over here, I think you've seen this before, from Calc 1, right? So, derivative of the first u prime times the second v, plus the first times derivative of the second, so u times v prime. That's not so easy. So with the understanding that u and v are functions of x, because we're differentiating with respect to x. All right, so the derivatives with respect to x. We can rewrite this, and it seems strange for a lot of people to rewrite these. Why would you rewrite it? Well, it looks strange, I'll be honest with you. So what do? They kind of rewrote it, and look like what they're doing over here. And I don't know what they're doing. It looked like they're subtracting, I'll write this down for you. Look like they're subtracting, and put it in red for you. Looks like they're subtracting u prime v from both sides. And what would they get? They would get u v prime equals d u v minus v prime, I'm sorry, u prime v. Then what do? They integrate both sides. They actually integrate both sides. So they integrate the left side and they integrate the right side. One term at a time, by the way. All right, it just looked crazy at this point. I mean, look at they're making something really easy, really difficult. Here's what they say, though, that this guy here is super easy to do. What are we doing? We're integrating the derivative of uv with respect to, I'm sorry, ddx uv with respect to dx. So that's just going to give us a uv. So this integration here is super simple. This integration here is super simple. So they write it down then. They write their simple result down. I'll put this over here. So they write this down over here as being, we just did this. You notice they're not putting this down yet. I'll tell you why they're not putting it down. We have not removed the integration symbol. Once we remove the integration symbol, we are hopeful that we'll put the C down once we remove it. Here's the problem though. We had an integration to begin with. We have another integration to deal with. Our hope is the integrations are going to get easier or stay the same. So we're hoping it gets easier or doesn't get more difficult. That's our hope. We're hoping that we take this thing here and we reduce it to an easier integration. Not always. All right, not always. Again, we're not saying you're at the stage yet where you can do this. The next page. All right, so these can be written down this way as well for the definite integral. And again, when I go through examples, we'll talk about definite integrals as well. That's when we have limits of integration. Write this over here. All I'm doing is copying what I did in the past, putting limits of integration on it. Again, what's our hope? We're hoping that this definite integral becomes easier over here. Not always, maybe more difficult. All right. By the way, I don't like the way this is written over here. So I'm going to go through my gold standard of what I like to write them down as. So I like to write down this way over here, or this way over here. All right. So what I'm going to claim over here is if we're going to do the problem, there's two things we need to identify. And I want to tell you what those things are. We need to identify the u in the problem. Once we know the u, we'll know the du. We also need to identify a dv. Once we know a dv, we'll know the v in the problem. Hopefully. This is all we're hoping for. So what I want to do is I want to take an example. We'll do many more examples. And over here, what I want to do is write down with hints how we're going to do the problem. So what I want to do is I want to do this over here. Whoops, let's go back to black. I want to do x e to the x dx. But what I want to do is I want to do that u dv equals u times v minus v du. What does this depend on? Identifying a u in the problem. I want to do this for you. Right now, someone says, how do you know what to do? I don't. I'm going to try something. So I'm going to try. I'm going to say this is going to be my u. Let me write that down for you. So I'm going to say u is equal to x. So I'm going to say u is equal to x. If I do that, though, I am forcing myself to do this now. I'll write this down. So I am now forcing myself to say dv is equal to e to the x dx. I'm actually forcing myself to do that. Here's what I have to do, though. I've got to write down the antiderivative and the derivative of this thing over here, one thing at a time. So let's do the derivative first. So what's du? When I say derivative, I should say differential. Du would be equal to dx. What would v equal? Well, what's the antiderivative of e to the x? That could be easier, e to the x. Now there is a constant integration, but I'm not going to deal with that until I get all the integrals removed, all the integrations removed. let's put this down. And I'm going to look at it one step at a time. So remember what I said. I said the U was X. Remember that? So I'm going to do this over here. And I got to put that in now. All right. So what's U? Whoops, I didn't mean to do that. The U is equal to X. I don't know what the V is yet, but I know something's going to go there later. I don't know the V yet. That goes down later. And then I get put the du down. What's du? It's dx. So all I did was I said u is x, du is dx. All right, let's keep going. Do I know what v is? I do. It's what? It's e to the x. Let me put in green. Okay. Question now is this. Has this integration become easier? A lot easier. So I'm going to put it down now. Let's put this over here. And again, we're learning. So what do you go here? I'm going to put that black ink now. It's going to be x, e to the x, minus, what's the answer of e to the x? E to the x. All symbols of integration have been removed in the right-hand side. I'm going to say some constant of integration. Now, granted, I'm new at this. So what do you recommend you do? Check it. How could you check it? You could differentiate it or look at the answer key. I'm going to differentiate it. And what am I hoping to get back after I differentiate it? I'm hoping to get back this. Let's see if we get that back. Now, someone says, didn't we just do that? We did. And it's going to happen to you. You can be doing the same problems over and over again. Just like when you get the exam, it's going to be really the same problem over and over again. Let's just differentiate them. Yep, deja vu all over again. So what do you get? 1 times e to the x plus x e to the x minus e to the x plus 0. This simplifies to x e to the x. Do we get back to what we expect? Of course we do. So we got this over here. We know the antiderivative now. Right. Is it work? Yeah. They written to work? Yeah. Okay. So here's the take-home message. When you're doing the assignments, you're going to have this written in front of you. And this possibly written in front of you. But I'm going to say all you need to know is this one over here. Where do we get this from the product rule? That's all we've done. Now, of course, work is over here for you. I want to put all the work, I just did the board for you. Hopefully you're able to follow that. What do we need to do? We need to start to work on examples. Of course, when I do the examples, they're going to start off simple. They're going to tell me what to do. I'll do exactly what they said to do. And then as I work through the problems, they're going to stop telling me what to do. Here's the deal, though. At some point, you should ask yourself, when do I get a chance to try? After we do the examples, there'll be a problem set for you to try. So we're going to do examples, and then it'll be your turn where you get a chance to try. You try. All right. Thank you for your attention. And again, if you need any assistance or help, please do feel free to come by during office hours. I'll be more than happy to help you.